I've talked about fans recently, most recently those really cheap Antec fans that were, and when I say cheap, I don't mean like build quality, although they were kind of cheapish. 5 fans for 20 bucks. And I told you guys you need to put them in your case and fill in as many fan slots as possible. And then I also said in that video, they need to start talking about airflow optimization, which is something I don't think I've talked about since like 2015 or 2014, something like that. So that's what we're gonna do today. Get amazing prices on the brands you love at Micro Center. Micro Center has over 30,000 items in stock, including desktops, laptops, computer components, monitors, TVs, and more. Not sure which parts to choose for your next build? Then use Micro Center's custom PC builder to find compatible parts, create your parts list, add them to your cart, and use same-day pickup at one of Micro Center's 25 locations nationwide. And if you're not comfortable building it, one of Micro Center's professional builders can build it for you as fast as same day for a fee. And if you need ideas for a build, then head to Micro Center's Build Showcase for great build inspiration, or submit your build for others to see. To see everything that Micro Center has to offer, click the link in the description below. This shouldn't be a very long video since it's a fairly simple topic, but it's one that I get people all the time that will email me little hand-drawn diagrams of like where they're putting their fans and the direction they're blowing and asking me, will that work? And in most instances, just about any fan configuration is going to work. I'd rather have a poorly optimized fan configuration than no fans at all, because any sort of air movement, whether efficient or inefficient, is still better than no air movement at all, especially when it comes to cooling your stuff. So I'm gonna use this case right here, and I need to take the side panel off, which I should have done before the start of this video, to kind of demonstrate the idea of not just positive pressure, negative pressure, and neutral pressure, which is a lot harder to achieve these days than you might think, just because of the amount of ventilation that's built into different cases and stuff now, but about how you can optimize positive, negative, and neutral if your fan layout doesn't necessarily support it. So what do I mean by that? First, positive pressure. Positive pressure means we have more air pressure inside the case than we have outside of it. So what's gonna happen is, as the air is moving in, it's gonna escape through every crack and crevice that it can. That means is the fans that are moving the air out of the chassis are not moving the air as fast as it's entering. Now, when we say move the air, we're referring to cubic foot per minute. Kind of funny. People don't like feet. They like meters. But apparently the official fan measurement is cubic foot per minute. Let that one sink in, world. You guys can write me your hate mail to nick@j2sense.com. That's NIC@j2sense.com. Anyway, moving forward, you can optimize your airflow in a couple of different ways. Ideally, equal exchange of air pressure, air in, air out, is good, because what's gonna happen is that means your fans are actually directing the air that you want them to go. So like we talked about, positive pressure means that the fans that are bringing air in, which are referred to as intake fans, the exhaust fans, and I'm highlighting the word exhaust, and we're writing it across the screen, exhaust, because of the amount of people I get writing me saying, how many outtake fans should I have? It's not an outtake, it's an exhaust. But the exhaust fans are obviously responsible for moving the air out of the chassis. But if you have more air coming in than you have airflow for exhaust, CFM, as I already went on a side rant about, then you get what's called positive pressure. So where does that extra air go? Well, it's gonna go anywhere there's extra places for it to escape. So in this case, you can see our little IO covers here are ventilated. Not a lot, but ventilation. Some air will escape out there. If you don't have all the fans, say, in the top of your case occupied, so you can see in the top here, we have full vent on top, but if we only had, say, one exhaust fan on the top, anywhere that there's not a fan or just a gap is also a place where air will escape. That's not necessarily a bad thing, because of the fact that positive pressure means you know you're bringing in more air than the case can get rid of in a certain amount of time. So you know you've fully just crammed as much air in your system as you can. Now for optimized cooling, you want to be able to exchange the air as fast as possible, which means whatever the volume is of your case, you want to take that full volume of air and replace it with cool air as fast as possible. If your fans are moving extra slow, whether it's positive pressure, negative pressure, neutral pressure, if they're moving extra slow, the air that's in here has time to heat up. As the air heats up, your components will heat up with it in a 1-to-1 ratio. So 1C of ambient, and ambient in this case being what is the air outside of the component. So outside of the CPU, outside the GPU, outside of the cooler, if it comes up 1 degree inside this case, your components and their cooling capacity will also increase 1C. It's a 1-to-1 ratio. It's kind of neat how that works out. So we want to be able to exchange that air as quick as possible. Now, when we talk about airflow optimization, realistically, if we were able to hook like 2 leaf blowers up to this that didn't blow warm air because they're compressed air, that would be the best because of the fact that you'd have a huge exchange of air. The problem is it would also be the noisiest. So you're gonna have to balance based on your noise taste as well. That's why more often than not, having as many fans in your system but turning at a slower speed will reduce noise, but keep the airflow volume or the CFM or the exchange of air rate higher than if they were running less fans at a higher RPM or even the same. What is neutral? Neutral is in between first and second. So neutral is when the air that's coming in is entering the system at the same rate the air is able to be exhausted. What you get with neutral usually is, that's kind of the preferred method, either positive or neutral. Now negative pressure is the opposite of positive pressure, and that's not just a polarity joke. If you have less air entering the case, then you have fans removing or exhausting air from the case, the air has to still be brought in somewhere. Those fans can't just say, well, we're not gonna pull air from anywhere. I guess we don't have enough to exhaust. You would then create a vacuum, and that's not gonna happen. So what we're gonna end up doing here is pulling air in through all those same cracks and crevices at which positive pressure would have pushed the air out. Negative pressure will pull the air in, because it is a slight vacuum. That's the only way it can pull air in. What you're also gonna pull in with that is dust. Unless your chassis has a filter over every single gap, which isn't the case, you're gonna find a higher dust buildup with negative pressure in your case than positive. Not only that, depending on where those gaps are, negative pressure could lead to overall higher temperatures in your volume. The delta is gonna be depending on many, many factors. How big is the case? How many fans are in the case? How negative is it? How big are the gaps that are in there? Where is that negative air entering and exiting again? Here's an example. You can see this fan right here does not cover all of these gaps. So we have this honeycomb grill down here, which means this fan, ideally, actually right now it says an intake fan. I don't remember how or when we did that, but it says an intake fan. So if it was an exhaust, we could potentially be blowing air out, pulling it right back in through this vent below it, and just having the air circulate in a circle like this. Now, if the air is doing this, right, if it's just sitting there going out and back in like this in a circle, that air is not touching any of the components. So that means it's not benefiting you at all. All it's doing is supplying air from wherever it can get it because of physics. Some other things to note when it comes to airflow optimization. This chassis, as you can see, can fit 2 fans on top, either 2 120s or 2 140s, and it can fit a 120 on the back. Now that's 3 fans. So let's say we put 2 140s on the top and this 120 on the back. Well, we've got 2 140 intakes. Now, just looking at the fan sizes alone, that would mean that potentially this could be a negative pressure setup. Now, even though we do have ventilation on the front, we have no ventilation, or not ventilation, but mesh on the front. We do have mesh, which is gonna slow down the airflow because it's gotta overcome the pressure of going, and the pressure drop of going through all these tiny holes. And this is why mesh size has been such a discussion point over the last few years when it comes to case design. You take this off the top, now you have a lot more airflow versus the giant slats, and you do this micro mesh, leading to a negative pressure situation. Just because you have more fans and more open airflow. People often forget about RPM. RPM is the true way to balance your airflow in your system, not just the number of fans. So we know that 140 millimeter fans move more volume of air. They're a higher CFM fan, RPM per RPM with a 120, just because it's a bigger blade, which means a bigger surface area to be able to move the air. What we also know about 140s is the fact that they are lesser pressure optimized. So what you can do in a situation like this, take your fans, get fan splitters if you need them, or if you're running any sort of fan that has a controller like Lee & fans, NZXT fans, Corsair fans, and start playing with the volume optimization through RPM. You would want your intake fans running at a higher RPM than your exhaust fans if they're having to overcome all of this mesh and stuff, and there's less of them, or even the same amount that you have exhaust fans, because your exhaust fans are pulling air from this open area inside the chassis. The intake fans are always going to be under the most resistance. Some cases are just poorly optimized with airflow at all when it comes to the front of the case. Solid tempered glass front panels have become a thing with small gaps around them to pull air in. If you think about all the directional changes the air has to make, it slows down the flow rate. You've got the micro mesh, like stuff like this, which you blow on it, you can barely feel any air going through it. My lungs can push a lot more pressure than any of these fans can. So you're gonna have to start playing around with the optimization of your airflow based solely on RPM. Now, Jay, how can I do that? How do I optimize it? Well, there's a couple of ways that I've showed in the past that you can do this. Some folks like it, some folks don't. It can get messy. It won't hurt anything with your system if you don't do this a lot, but nothing will hurt using a stick of incense. You can get it off of Amazon, super, super cheap, a couple of bucks. You burn it, you hold it in front of your case, and you'll see the air enter. Okay, at that point, you're seeing the air go in, you know you're good. Sticking it inside your case at that point doesn't do anything, it doesn't matter. The air is gonna go where it's gonna go. What I start to do by checking which optimization I currently have with my fan airflow, and I'll even show like an 8-year-old video clip here, I start holding it around all the gaps. I would hold it right here in the rear where I've got this ventilation. If I put my incense stick in front of it and I see it pushing out, then I know I have positive pressure. If I see it pulling it in, I know I have negative pressure. If I see it just coming up normally, like normal convection, then I'll know I've got neutral pressure. Neutral's ideal, slightly positive is best, in my opinion. But I would start going all over the case. If I go underneath, like if I hold it in front and I see it going up in there and the system isn't on, that tells me we'd probably have negative. And the reason why I say system isn't on, because the power supply fan facing the bottom would pull air in through there. So that's something to keep in mind. But I would have the case all sealed up by the way I'm doing that. Side panel has to be on for obvious reasons. This case right here would create no pressure. It would just be straight up neutral at that point because of the fact that this air is just gonna go wherever, this air is gonna pull from there. So incense is a cheap, easy way, one, to make your room smell nice for a little while, and two, there's not nearly enough of that burning fuel to get gunked up on your fans or make anything sticky. Just ask anyone that is like a habitual vaping in front of their system, how often they replace their fans, because believe it or not, that vape juice and the vapor alone will destroy fans pretty quickly. But I just wanted to make this video kind of talking about airflow because of the fact that I see a lot of discussions taking place whenever we talk about fans, but people never talk about RPM. RPM is king. You can use RPM to overcome any of the issues that you have with your chassis, maybe not being as airflow optimized. So intake fans should be running as fast as you can audibly stand, or come up with fan curves, obviously, so that when they're idle, they don't have to do much. When you start putting the system under load, they increase the air volume coming in. Then what you do is after you've set your intake fans where you want them, that is where you start adjusting the RPM of your exhaust fans to where as you're using your incense, you can take it to some of these vents right here that have no fans in front of them and find them slightly pushed out. So the smoke is barely moving away from it, but still climbing through convection. Any airflow, even the smallest amount of airflow, overcomes convection. Convection is a very weak force. So if you have even the slightest amount of negative pressure in your case, the smoke will go into the vent. Positive pressure, a lot of positive pressure, it'll blow out violently from that vent. If the smoke's going in, you gotta turn up your intake RPM or slow down your exhaust RPM. If it's blowing out hard, slow down your intakes until it stops. Leave your exhausts where they are. Just slow down your intake, unless the exhausts aren't running at all, or they're running really low RPM. Slow down your intake until it starts to become a bit more neutral. Something we haven't talked about in a while, but definitely food for thought. Now the same thing holds true if your chassis is one of those Lee vertical 011 dynamic types where the intakes are on the bottom. You're just gonna have an updraft type of airflow. So it's gonna pull in through the bottom, go up and exhaust out the top. It's the same exact principles that apply. It's just turned, that's the only difference. All right guys, it's been a while since we've done a video like this. I'm gonna go back to these kinds of topics. I feel like they help a lot of people. It's free stuff you can do with your system, unless you have to add more case fans. But there's lots of things you could probably do to optimize your overall performance that you may not even realize is unoptimized until you start playing around like this. So I recommend Get a stick of incense, burn it responsibly, be safe with it. Don't just like, go waving it around your house and give it to like your 2-year-old brother to go start like dancing on furniture and your curtains with it. That's bad. Don't do that. Make your room smell nice. Get your case flow optimized. You might even see some component temperature drop in the process. All right, guys, thanks for watching. Any more topics like this you'd like to see, make sure you comment down below or email me at jsusense.com. Tweet me at Twitter at jsusense, or heck, you can even TikTok me at jsusenseofficial. All right, guys, we'll see you in the next one.